This is the OCR GCSE 9 to 1 Maths paper 3 from the foundation tier, and it's from the June 2019 series, and this paper is a calculator paper. Question number 1. For part A, we have to write down the mathematical name of this type of angle. Choose from the list in the box. Well, this angle is more than 90 degrees, but less than 180 degrees, and therefore, for part A, we have an obtuse angle. Now for part B, we have to measure angle G. Well, if we grab our protractor, as we see here, and let's just shrink down this protractor, and if we line up everything as we see here, what you can see is we're going from this angle to this angle. You can see here we have an angle of 45 degrees. Question number 2 for part A, we have to write down 6 to 14 as a ratio in its simplest form. Well, what we can do is divide both sides by 2, because both of these numbers are even. So if we divide both sides by 2, we would have 3 to 7. So we have 3 to 7. And now for part B, the ratio 20 to 50 can be written in the form 1 to n. We have to find the value of n. Well, we want a 1 over here, and so therefore, to get a 1, we need to do 20 divided by 20 to get 1. And if we do 50 divided by 20, 50 divided by 20, that's 2.5. So we have 1 to 2.5, and therefore n is equal to... Question number 3, we have to insert brackets to make each of these calculations correct. We have here 5 times by 3 take away 1 equals 10. Well, we know that 5 times by, let's just write this down, 5 times by 2 is equal to 10. So you'll notice 3 take 1 is 2. And so therefore, if we insert brackets here, we have 5 times by 2 equals 10. Next, we have 3 plus 6 take away 2 divided by 2 equals 3.5. Well, you'll notice over here we've got a 3.5, and 3.5 is equal to 7 over 2. Okay, so 3.5 rather is equal to 7 over 2. And here we do have a divide by 2. And you'll notice 3 plus 6, that's 9, and take away 2, that's 7. So if we insert the brackets here, then inside this bracket we'd have 7. We'd have 7 divided by 2, which is 3.5. Question number 4, we have to work out 20% of 40. Well, 20%, that's the same as 0.2 as a decimal, so we've got 0.2 times by 40. So if we work this out, 0.2 times by 40, you'd find this to equal 8, and therefore 20% of 40 is equal to 8. Question number 5, a shape is drawn on a 1 centimeter grid, that's what we see here, and we have to find the perimeter of the shape. Well, here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as our perimeter. So our perimeter is 10 centimeters. And for part B, how many lines of symmetry does the shape have? Well, here we'd only have 1 line of symmetry. That will be over here. And so therefore we have 1 line of symmetry. Question number 6. Here are the first 5 multiples of 15, and we have to write down the first 5 multiples of 30. Well, we begin with 30, then we've got 60, then we've got 90, then we've got 120, and then we have 150. So all I've just done is 30 times by 1, 30 times 2, 30 times 3, 30 times 4, and 30 times 5 to get the first 5 multiples of 30. And now for part B, we have to write down the lowest common multiple of 15 and 30. You'd find the lowest common multiple to be 30. So the lowest common multiple is 30. Question number 7. P is shown on this grid, and for part A we have to write down the coordinates of P. Well, we're going 2 across and 3 up, so the coordinates of P are 2, 3. And now for part B we have to draw the line x equals minus 2 on the grid. Well, the line x equals minus 2, that will be over here. We have here the line x equals minus 2. Question number 8, we have to find the value of g. We have to find the value of 3g minus h when g equals 4 and h equals 5. So what you'd find over here then is when g equals 4 and h equals 5, we have 3 lots of 4 minus 5, so we've got 12 minus 5, which is 7. So we've got the value of 3g minus h given these conditions is equal to 7. Question number 9. Here are the first 3 patterns in a sequence. We've got pattern 1, we've got 1 dot, pattern 2, we've got 2 by 2, which is 4 dots, and pattern 3, we've got 3 by 3, which is 9 dots. And part A, we have to draw pattern 4 in this sequence. Well, here we'd just have 4 dots by 4 dots. So what we'd have in total is 16 dots. So you can see here we've got 16 dots. And for part B, without drawing it, work out how many dots there are in pattern A, explain how you decide. Well, here, what we did with pattern 1 is we squared 1, pattern 2 we squared 4, pattern 3 we squared 3, and pattern 4 we squared 4. So with pattern 8 we'd have to square 8, which is 64. So the reason we have 64 dots is because we have 8 rows of 8 give is 64. And for part C, pattern N has 196 dots, and we have to find the value of N. Well, here, if we know the number of dots we have, we can square root that to find out the pattern number. So the square root of 196, you'd find that to equal 14, and therefore here, N is equal to 14. Question number 10. The pie chart shows how Jack spent his time one evening. So he was gaming, homework, eating and reading. On which activity did Jack spend most time? Well, that's the one with the largest angle. Of course, here we would have gaming. And for part B, Jack says, I spent a third of my time gaming. Show that he's not correct. Well, in total we have 360 degrees in a point, and 150 of those corresponds to gaming. So 150 divided by 360, you'd find this to equal 5/12. And because this does not equal the 1/3, we can therefore conclude he would be incorrect. Now for part C, the pie chart represents 5 hours. Find the time in hours and minutes that Jack spent reading. Well, what we need to do is find out this angle here. So to find out the angle for reading, we have 360, again we've got angles around a point, take away the 150, take away 90, take away 30. So if we work all of this out, 360, take away 150, take away 90, take away 30, you'd find this to equal 90. So therefore, we've got 90 degrees represented by reading. So we've got 5 hours and 90 degrees, that would represent 1/4, because 90 divided by 360 gives us 1/4, and therefore we've got 1/4 of 5 hours, which is equal to 5/4 hours, which is 1 hour and 1/4 hours. And the 1/4 hour, that would represent 15 minutes. So we've got 1 hour, 15 minutes. So we've got 1 hour, 15 minutes. Question number 11. Megan's cafe sells ice cream. Customers can have a tub or a cone and a wafer or no wafer. They can choose vanilla, lemon or chocolate ice cream. This frequency tree shows the number of people making some of the choices. And for part A, Anaya buys an ice cream. One choice she can make is a cone, no wafer and vanilla. How many different choices can she make? So we've got a cone, and then we've got no wafer, and then we can either get vanilla, lemon or chocolate. Well, we can have here cone, no wafer and vanilla, so that's 3. Or we can have cone, no wafer and lemon, or we can have cone, no wafer and chocolate. So therefore she can make 12 different choices. And for part B we have to complete the frequency tree. Well, over here we can find out the total who want wafer. That will be 4 plus 10 plus 10, which is 24. So we've got 24 with wafer, and therefore no wafer. That will be 65 take away 24, which is 41. And therefore for chocolate, that will be 41 take away 12, take away 15, which is 14. So we've got 14 over here. And now for part C, which flavour of ice cream was most popular? Show how you decide. Well, if we find out the total for vanilla we've got 4 plus 12 plus 9 plus 1. So for vanilla we have 4 plus 12 plus 9 plus 1, which is 26. And for lemon we have 10 plus 15 plus 10 plus 0. So we have 10 plus 15 plus 10 plus 0. So adding these together, it turns out we would get 35. And for chocolate, we would have 10 plus 14 plus 11 plus 4. So we have 10 plus 14 plus 11 plus 4, which equals 39. And therefore, the ice cream flavour which is most popular will be chocolate. Question number 12. We have to solve 4x plus 5 equals 35. Well, if we subtract 5 from both sides, you will find 4x to equal 30. And now if we divide both sides by 4, x will equal 30 divided by 4, which is 15 over 2, which is 7.5. So x is equal to... Question number 13. Delroy drives 240 miles. His car averages 40 miles per gallon of petrol. Petrol costs £1.38 per litre. 1 gallon is 4.5 litres. How much does Delroy spend on petrol for this journey? First of all, we can find out the number of gallons. The number of gallons is equal to, well, if he drives 240 miles and his car averages 40 miles per gallon, then here we'd have 240 divided by 40, which is 6. So he uses 6 gallons of petrol. Now, we know that petrol costs £1.38 per litre, and we know that 1 gallon is equal to 4.5 litres. So therefore, what we have is 6 times by 4.5, which is equal to, if we work this out, 27. So he uses 27 litres of petrol, and therefore the cost of this, we've got £1.30 per litre of petrol. He's using 27 litres, so multiplying 130 by 27, you'd find here we get £35 and 10p. So we've got £35 and 10p. Question number 14. Joan makes cups of tea and coffee at a lunch. Each cup requires 250 millilitres of boiling water. She has a kettle that boils up to 1.7 litres of water each time. She boils 10 litres of water in an urn. She then uses the kettle to boil the rest of the water she needs. We need to find the least number of times that Joan needs to boil the kettle to make 56 cups. Show how you decide. First of all, we can find out the amount of boiling water required. Each cup requires 250 millilitres, and we've got 56 cups, so 250 times by 56, you'd find this to equal 14,000. So therefore, 14,000 millilitres of boiling water is required. Now, what we can do is, well, over here we've got litres, here we've got litres, and here we've got millilitres. We can convert this millilitres into litres. To go from millilitres to litres, we would have to divide by 1,000, and litres to millilitres we'd have to times by 1,000. So if we divide this by 1,000, of course 14 litres of boiling water is required. So therefore, we know already that 10 litres of water are boiled in an urn. So therefore what we need to do is need 14 litres take away 10 litres, which is 4 litres, with the kettle. So 4 litres are required when we boil water using a kettle, and therefore to find out the number of boils we need, so what we'd have to do here is 4 divided by 1.7. 4 divided by 1.7, that's 2.35, etc. And therefore what we need to do is boil the kettle 3 times. So therefore we need to boil the kettle 3 times. Question number 15. For part A, 50 sweets weigh 200 grams. If each sweet weighs the same, we have to work out the weight of 7 sweets. Well, first of all, we can find the weight of one sweet. If 50 sweets weigh 200 grams, then 1 sweet, this will equal 200 divided by 50, which is 40. So 1 sweet weighs 4 grams, because 200 divided by 50 is equal to 4, and therefore for 7 sweets we would have to do 4 times by 7, which is 28. So 7 sweets weigh 28 grams. And now for part B, B is directly proportional to A. B is 10 when A is 8. We have to work out B when A is equal to 9. So if B is directly proportional to A, that means that B, proportional symbol A, and therefore B equals some constant K multiplied by A. And we know that when A equals 8, B equals 10. So we've got 10 equals K times by 8. And therefore K is equal to, if we work this out, we have 10 divided by 8, which is 1.25. So therefore, B is equal to 1.25 A. And when A is equal to 9, B is equal to 1.25 times by 9. So if I times this by 9, we get 11.25. So therefore we get 11.25. And now for part C, a graph is drawn, and we have to explain how you know that y is not directly proportional to x. Well, although this curve passes through the origin, we don't have a straight line, and therefore we can't conclude that y is not directly proportional to x. Question number 16. This is a plan view of a 3D object, and we have to complete the diagram below to show the front view of the 3D object from A. Well, if we're looking from A, then this length here, which is, if we measure it using a ruler, is roughly 1.5 centimeters, and here we also have 1.5 centimeters, so that's for this length here. And if we consider this length over here, we would have 2.2, and the distance between the edge of this square and here is 1.9. So after 1.9 centimeters, we have 2.2. So from here, we have roughly, well, let's check that again, that is indeed 2.2. So from here, we've got 2.2. And then, of course, what you need to recognize is, because we're looking at it from this side, would have two parts to this. Would have essentially this part over here, let's just draw it on, would have this over here if we draw it on accurately. And then we've also got a similar situation over here. So we've essentially split this up into two bits from the front view. So we have to do the same thing over here by dividing this by 2, and the height, well, that doesn't really matter what that is, as long as we're consistent. So let's just bring it up to here. And then what we need to do is split this up into two equal parts. So we'd have a line going down here. So here is our completed diagram. Question number 17. A grain of salt weighs 6.48 times 10 to the minus 5 kilograms on average. A packet contains 0.35 kilograms of salt. And for part A, we have to use this information to calculate the number of grains of salt in the packet. Well, if the packet contains this much salt and a grain of salt weighs this much, what we can conclude then is the number of grains of salt will be equal to 0.35 divided by 6.48 times by 10 to the minus 5. So if we work this out, we would have 0.35 divided by 6.48 times 10 to the minus 5, which is 5401.23, etc. So therefore, for the number of grains of salt we would have 5402. And now for part B, we have to explain why our answer to part A is unlikely to be the actual number of grains of salt in the packet. Of course, each grain of salt varies in weight, height, etc. So that's why we can't conclude that this will be the actual number of grains of salt. Question number 18. Tom researches the weights of plant seeds. One poppy seed weighs 3 times 10 to the minus 4 grams. 250 pumpkin seeds weigh 21 grams. One sesame seed weighs 3.64 times 10 to the minus 6 kilograms. And we have to write the 3 types of seed in order according to the weight of one seed. Write the lightest type of seed first. You must show how you decide. Well, here, first of all, we've got 250 pumpkin seeds weighing 21 grams. So we can find out the weight of one pump. Well, let's just do each of these separately, actually. We've got a poppy seed. That would have weight 3 times by 10 to the minus 4 grams. And for the pumpkin seeds, well, we've got 21 divided by 250, which is 0.084 grams. And if we write this in standard form, well, what we'd have to do is move this decimal place 2 units to the right. So we've got 8.4 times 10 to the minus 2 grams. And if we consider the sesame seeds, well, what we'd have to do is convert the kilograms to grams. We can do that by timesing by 1,000. So 3.64 times 10 to the minus 6 times by 1,000. It turns out here we get 3.64 times 10 to the minus 3 grams. And therefore, what we can do is compare the powers of 10 to see which one will be the smallest. So the first one is this is the lightest, followed by this, followed by this. So when we come to write down question number 19. For part A, this spinner has 2 grey sections, 2 white sections and 1 black section. Vlad says the probability of the spinner landing on black is 1/5. Explain why he is incorrect. Well, over here, if we work out the angle represented by black, so if we line everything up, just make this slightly smaller, you can see we've got an angle of, well, we've got 90. Let's just work this out. We're going from 90 to here. So we get an angle of 28 degrees. So we've got here an angle of about 28 degrees. Now 28 over 360, if we work this out, turns out here we get 7 over 90. And clearly this is not equal to 1/5, and therefore he will be incorrect. Now for part B, the graph shows the cost of a litre of petrol for the last 6 months of 2017, that's what we see here, and we have to explain why this graph is misleading. Well, one reason is the graph does not start at 0. We don't know anything about cost of petrol going up to that. Question number 20. Sophie is organising a raffle. Each raffle ticket costs 50p. She sells 400 tickets. The probability that a ticket chosen at random wins a prize is 0.1. Each winning ticket receives a prize of £3. Sophie says, I expect the raffle to make over £100 profit. Show that Sophie is wrong. Well, you can see how much she sells. We've got 400 multiplied by 50p, which is the same as £0.5. So she sells 200 tickets. And, well, she sells £200 worth of tickets. And the probability that we win is 0.1. So we can find out the expected number of winning tickets. So we would have the number of winning tickets equaling 400 times by 0.1, which is 40. So we expect to have 40 winning tickets, and therefore she would have to pay out 40 times by 3, which is £120. And if she sells £200 worth of tickets and she's paying out £120, you can therefore see that the profit then is equal to 200 take away 120, which is equal to 80. So the profit is £80, which does not equal the £100 she is suggesting, and therefore you can conclude that Sophie is wrong. Question number 21. A bag contains some counters. There are only 300 counters in the bag. There are only red, white and blue counters in the bag. The probability of picking a blue counter is 23 over 50, and the ratio of red counters to white counters is 2 to 1. We have to calculate the number of red counters in the bag. Well, the probability that we get a blue counter, that is equal to some value divided by 300. We've got 300 counters in total, and of those, some of them are blue. And we know that this will eventually simplify to 23 over 50. Now, to go from 300 to 50, we have to divide by 6. So if I multiply 23 by 6, we get 138. So therefore, what you can see then is we have 138 blue. And so for the rest of the counters, we have 300 take away the 138. So we've got 300 take away this, which is 162. So we've got 162 counters which are either blue or which are either red or white. And you can see using this ratio, 2 plus 1, that gives us 3. So we've got 3 parts, and therefore 162 divided by 3, if we work this out, we get 54. So here we have 54 per part. And therefore, to find out how many red counters there are, we've got two parts red, so we've got 2 times by 54, which is 108. So we have 108 red counters. Question number 22, we have to construct the perpendicular from the point P to the line AB. Show all your construction lines. Well, with our compass, if we put the pointy bit at P, as we see here, and then if we intersect our line AB at 2 points, here and also here, you can see there's 2 points over here where our arcs have essentially crossed AB. And then if we put the pointy bit to one of those intersection points and make sure that the length over here from the pointy bit to the pencil is more than half of this portion here, if we draw a line like that and retaining the same length and put the other pointy bit here where the other intersection line is, and then put a line here like so, what we can now do is join those up with a straight line. So if we join those up with a straight line, you can see here we've got the perpendicular from the point P to the line AB, and here we have 90 degrees. Question number 23. The diagram shows a regular hexagon made from 6 equilateral triangles, and each side is 10 centimeters, and the angle ACB is a right angle, and we have to show for part A that AC is equal to 8.66, correct to 3 significant figures. Well, if we have equilateral triangles, then here we would have, if we draw this on accurately from here to here, we would have 10 centimeters, and from here to here we also have 10 centimeters. And if we have an equilateral triangle, this angle here is 60, and therefore this angle is 30, and therefore this angle is also 30, and this angle here is 60, and notice 30 plus 30 gives 60. So now we have enough information to work out what AC is. Let's draw out the triangle again. We've got here, if we draw C, B and A, we have 10 centimeters here. We're working out AC and we've been given 60 degrees here. Here is the opposite. Let's just label the sides. We've got here the hypotenuse. Here we've got the opposite. So what connects the opposite to the hypotenuse is sine. So we've got sine 60 equals opposite AC divided by hypotenuse 10. So therefore, AC is equal to 10 times by the sine of 60. So we've got 10 times by the sine of 60, which is 5 root 3, being equivalent to 8.6602, etc. So, what we can conclude then, AC is equal to 8.66 given to 3 significant figures. And now for the first part of part B, we have to show that the area of the triangle ACB is 21.7 centimeters squared, correct to 3 significant figures. Well, to work out the area of a triangle, what we would need to do here is find out CB, and we can do that using Pythagoras. So if we draw on this triangle once again, we've got a triangle over here. We said here we've got A, CB. We've got 10 here. We've got 5 root 3, and it's easier to use your exact value. We can now find out what CB is. So we've got CB squared plus AC squared, which is 5 root 3 squared. This is equal to 10 squared. So we can find out what CB squared is equal to. That's equal to 10 squared, take away 5 root 3 squared, which is 25. And therefore CB is equal to square root of 25, which is 5. So we've got 5 here. And therefore the area is equal to 1/2 times by the base times by the height. So we've got 1/2 times 5 times by 5 root 3. So we've got 1/2 times by 5 times by 5 root 3, which is 21.65, etc. So we've got 21.7 centimeters squared given to 3 significant figures. And now we have to find the area of the hexagon, giving your answer to an appropriate degree of accuracy. So if we go back to this diagram, this triangle is the same as this triangle here. So this triangle is the same as this triangle here. And therefore what you can see is, if I draw it on, what you can see is we've got, if I just draw on the other sides, you can see here we've got let's just count them actually. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 of those triangles. So therefore for the area is equal to 12 lots of the value we just found here. And don't use your rounded answer, use the unrounded answer. So if I times this by 12, we end up with 259.807, etc. centimeters squared. So we have to an appropriate degree of accuracy 259.8 given to 1 decimal place. Question number 24. The graph shows two parallel lines, line A and line B. Line A has equation y equals 6x plus 7, and line B passes through the point 426. We have to find an equation for line B. Well, what you can see here is, because the lines are parallel, the gradient of line B is the same as the gradient of A, which is 6. So therefore, if we use y equals mx plus c to help us find the equation of the straight line, what we would have then is y, which is equal to 26, equals m, the gradient, times by x, which is 4, plus c. 26 is equal to 24 plus c, and therefore c is equal to 2. And what we can conclude from that then is our equation of the line B is y equals 6x plus. Question number 25. Are these two triangles mathematically similar? Show how you decide. Well, to find out the length scale factor, you can see to go from the 10 to the 15, well, the length scale factor will be 15 divided by 10, which is 1.5. So here we're timesing by 1.5. And to go from 6 to 11, well, 11 divided by 6, that will be 1.83. So to go from here to here, we have to times by 1.83, etc. And therefore, because the scale factors aren't the same, what we can conclude is they're not mathematically similar because the corresponding ratios are not the same. Question 26. A number g is given as 4.05 correct to 2 decimal places, and we have to write down the error interval for g. Well, what we need to do is, if this number is given correct to 2 decimal places, then the upper bound is equal to 4.055 and the lower bound is equal to 4.045. And these numbers round to this to 2 decimal places. And therefore for the error interval we have 4.045 to 4.055. And now a number h is given as 3 truncated to one significant figure. We have to complete the error interval. Well, here h can include 3 but it can't include 4. We can have everything include up to 4 but not including 4. Question number 27, we have to solve by factorising x squared plus 3x minus 10 equals 0. Well, we need two numbers here which multiply to give minus 10 and add to give the 3. You'd find those two numbers to be minus 5, rather you'd find those two numbers to be 5 and minus 2. And therefore when we come to factorise, we would have x plus 5 lots of x minus 2 equaling 0. So either the x plus 5 is equal to 0 or the x minus 2 is equal to 0, from which you can see from here x is equal to minus 5, or from here x is equal to 2. So we have x equals 2 and x equals minus 5. Question number 28. For part A we have to simplify the following. For the first part we have to simplify h to the 3 times h to the minus 3. Well, here we have to use the laws of indices. A to the power of m times a to the n. When we've got the same base when we're timesing, we add the powers. And therefore what we have here is h to the power of 3 plus minus 3, which is h to the power of 0, which is equal to 1. So therefore this is equal to 1. And now for the next part, we've got f to the 9 divided by f to the 3. Well, a similar rule, if we've got a to the m divided by a to the n, we've got the same base when we're dividing. Here we'd have to subtract the powers. So we'd have a to the power of m minus n, and using that here, what we have is f to the power of 9 minus 3, which is f to the power of 6. So here we would have f to the power of 6. And now for part B, the length of each side of a plastic cube is 2a millimeters. A cube has a mass of 32 squared grams, and we have to find an expression for the density of the cube in its simplest form. Give the units for your answer. Well, over here, density is equal to mass over volume. So, to find out the density, we would have the mass, which is 32a squared divided by the volume. Well, the volume will be equal to 2a all cubed. And the reason it's 2a all cubed is because we've got a cube with each length being 2a millimeters. And if we write down the units, we have grams per millimeter cubed. So therefore we would have 32a squared divided by, well, 2a all cubed, that's 8a cubed, and the units, we've got grams per millimeters cubed. So 32 divided by 8, that's 4. So we've got 4, and then here we've got a squared divided by a cubed. Well, using a similar law to what we said here, we subtract the powers. 2 take away 3 is minus 1. So here we've got 4a to the minus 1 grams per millimeters cubed. So we've got 4a to the power of minus 1, and the units are grams per millimeters cubed.